Hello students, in this video we'll see the solution to the first problem on the quiz. In this problem we're given that there are two bowls, each of which have 8 marbles. The first bowl has 4 maize and 4 blue marbles, and the second bowl has 2 maize and 6 blue marbles. A bowl is chosen randomly, and we'll assume that each bowl is equally likely to be chosen. And then a marble is randomly selected from that bowl. We would like to know the probability that the first bowl was chosen given that the marble was maize. So let's define some events. Let's let B1 be the event that bowl 1 was chosen. And similarly, we'll let B2 be the event that bowl 2 was chosen. We have maize, let M be the event that a maize ball that a maize marble was selected. And let's similarly let B, with no subscript, be the event that blue was selected. It is very important to define these events before you solve the problem. We would now like to find the probability that the first bowl was selected, B1, given that maize was selected. Now, we recall the definition of conditional probabilities. We recall the probability of A given B is the probability of A and B over the probability of B. We can use this relationship in the reverse order and say the probability of B given A is the probability of B and A over the probability of A. So we can notice now that both of these two expressions on the numerators are the same. These are equal. And so what we can do now is we can replace the probability of B given A with, well, the probability of B given A is this probability, A and B, which we can write as the probability, so this on top over here will be the probability of B times the probability of A given B. So I'll have probability of A given B, so I can flip the order, times the probability of B divided by the probability of A. So we'll use this relationship, this is a form of Bayes' theorem, to solve our problem. So we go back to this problem. So the probability of B1 given M is the probability of, flip them, M given B1. And then the probability of B goes on top, so that's the probability of B1 for our problem, over the probability of the event A. Now, the probability of M, so this is the probability of M given B1 times the probability of B1. Now we can use Bayes again. This is probability of M given B1, probability of B1 plus probability of M given B2 times the probability of B2. And so now we can fill in what each of these things is. So the probability of a maize marble, given that you selected bag 1, well, bag 1 has 4 maize and 4 blue marbles. So you get a 50-50 chance of getting a maize or blue, so that's going to be 1/2. And then you have the probability of bowl 1 being selected, which is also 1/2. We can notice that this probability on top is exactly the same as the first term over here, so I get a 1/2 and then a 1/2. And then plus, and then the probability of a maize given bag 2, well, bag 2 is 2 maize and 6 blue, so you get a 1/4 probability of selecting maize times a 1/2. Now there's a common factor of 1/2 everywhere in this problem, so we can cancel it out. So what we get over here is we get a factor of 1/2 over 3/4, so 1/2 over 3/4, which we write as 1/2 times 4/3. So that 4 will cancel out. That will be a 2, that will be a 1. So we get, there's a 2/3 probability of selecting a bowl number 1 given that the marble was maize. Thank you very much.